Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over the relationship between the standard change in free energy of a reaction and the equilibrium constant of that reaction. So let's get into this. Let's review what the standard change of a in free energy of a reaction is, or at least what it determines. I've said in other videos that um, the change in the standard free energy of a reaction determines the spontaneity of a reaction when reactants and products are in their standard states. So that's what the delta G, standard delta G of a reaction is, or at least what it determines. The K, which is your equilibrium constant, that equilibrium constant of reaction determines how far a reaction will go towards products. So you can see kind of right away that these two should be related to each other, because if we're looking at the spontaneity of a reaction, we're looking at how far that reaction is going to go towards products. So if we get a negative delta G of a reaction, the standard free energy change of a reaction, if that's negative, we say it's going to spontaneously go towards products. So we would then expect that K is going to be relatively large. If your standard free energy change of a reaction is going to be positive, then we would say that's really not going to go towards the product. The forward reaction is not going to be spontaneous. It's the reverse reaction that's going to be spontaneous. So in that case, reactants would be favored. And so we would expect K to be small. So we can see right away that there should be a relationship. So if we look at the equilibrium constant, K, we could say then the equilibrium constant K is going to become larger as the change in the standard free energy of a reaction becomes more negative. So that what that says is if going from reactants to products, your standard free energy change is negative, you have less free energy in your products than you start out in reactants. That's going to favor the products. So your K is going to be larger. If going from reactants to products, you gain free energy, meaning your change in the standard free energy is positive, then that's going to be uh, that's not going to favor the forward reaction. It's not going to be spontaneous, and so your it's going to favor the reactant. So K is going to be small in that regard. So if you look at a situation at equilibrium, we can figure out what the relationship is going to be between the equilibrium constant and the change in the standard free energy of the reaction. So if we take the point at equilibrium, we know that the reaction quotient is equal to the reaction equilibrium constant. And we also know that at equilibrium, your non-standard change in the free energy of a reaction is going to be equal to zero. So if we take this equation for the non-standard free energy change of a reaction, we saw that that's equal to the standard free energy change of a reaction plus the equilibrium constant, the ideal gas law constant multiplied by the temperature in Kelvin multiplied by the natural log of the reaction quotient. So if we take these and put them into the equation, so since the non-standard free energy change of reaction is zero, we put that there. And then Q then becomes K because they're equal. So we know that zero is equal to the standard free energy change of the reaction plus RT ln of K. So if we rearrange this, we bring this over to this side, it becomes negative. And then we bring the negative over, we get the relationship between the standard free energy change of the reaction related to the equilibrium constant. So this is a good equation to know. And again, If we are dealing with reactions that involve gases, then we're going to be using Kp in the form of pressures. And then for reaction involving solutions, we got Kc for concentrations. So what does this tell us? So if K is less than 1, right? So remember, if K is less than 1, that's going to be favoring reactants. So we can see that the natural log of K is going to be negative, and therefore the standard free energy change of the reaction is going to be positive, therefore not spontaneous. So under standard conditions, then, where Q is equal to 1, spontaneous, it's going to be spontaneous in the reverse reaction, not in the forward reaction. If K is larger than 1, then ln of K, the natural log of K, is going to be positive, and therefore the standard free energy change of the reaction is going to be negative. Therefore, the forward reaction is going to be spontaneous. So under standard conditions, again, Q equals 1, it's going to be spontaneous in the forward reaction. And then finally, if K is equal to 1, that's going to be going to lead to ln of K, the natural log of K is 0, and the standard free energy change of the reaction is 0 as well. So that means that the reaction is at equilibrium under standard conditions. And so that shows you the relationship between the standard free energy change of a reaction and the equilibrium constant, the equilibrium of a reaction. Is it favoring the reactants or is it favoring the products? That's all I have for this video. I hope you enjoyed this video. If this video was interesting to you, if you learned from this video, then please, by all means, like the video. Hit that like button right there. Share the video with others. Also, subscribe to my channel. Make sure you do that. And also, hit the notification bell. And finally, put a comment down in the comment section. Let me know what you think. Ask me questions if you got them. Thanks for joining me, and have a great day.